delivering software faster but safely. Those are two key things that are our responsibility as builders, and we want to make them right. Now, building serverless applications can help with the speed side of things. Why? Because when you get rid of all the issues and worries about dealing with infrastructure, you're freeing up engineering time that you can repurpose into what really matters, getting those software features faster to your users. But speed is only one side of the equation. How about safety? I'm sure no one in this room has ever started a deployment or a change nervously, not knowing if you're going to break production or not. Am I right? Well, today I'm going to showcase some features that will give you peace of mind when releasing your serverless applications, so that you can hit that deployment button without fear with things like automated rollback and things like that. So today you're getting speed and safety from this session. By the end of the session, you'll know how to author, test, and debug serverless applications very quickly using the right tools so that you can unlock the power and the speed of serverless applications, allowing you to build anything serverless, anytime, and anywhere. So let's get started. A couple of hours ago, you sat down, you opened your IDE. If you're like me, you put in some jazz to get in the zone, and you've cranked out some really great code in Lambda. And you're ready to ship that to your customers. But because you're a great developer that knows manual deployments are bad, you want to automate it. You want to define your application as code. At AWS, we do this with CloudFormation. CloudFormation is a great service. It's a service that allows you to create, manage, and update a collection of AWS resources in a controlled and predictable way. Now, the beauty of CloudFormation for builders like us is that it's declarative, meaning that you define how the architecture should look like. But you don't have to worry about orchestrating all the changes for your application. All of that is taken care of on our behalf by CloudFormation. You can certainly define serverless applications using CloudFormation. But as you start using or building more complex and more distributed serverless applications comprised by, say, hundreds or thousands of Lambda functions, you're going to want the power of CloudFormation, but also the ability to define those serverless components with a lot less code. Well, this is exactly where SAM comes in. SAM is the AWS Serverless Application Model. It makes it easy for you to create and manage serverless application, and it's also a friendly squirrel, only AWS service with a mascot. And don't ask me why. Well, maybe ask me outside after my session. Now, So SAM basically makes it really easy for us to manage and create serverless applications. You can think of it as a higher level abstraction to CloudFormation. So you're still using CloudFormation in the background. You write your templates in a greatly simplified syntax in SAM, but you upload that to CloudFormation. And it supports everything that CloudFormation does. Now, to show you how easy it is, let me show you the SAM template that I'm going to be deploying in the first demo today. This is a full SAM template for an application comprised by an API gateway and a Lambda function with all the wirings and permissions needed so that they talk to each other. A user hits the API gateway, and then a Lambda function is triggered. Only 14 lines of code. Very neat. Now, let's go through all the components in the template. The first section of the template, you need to define that this is actually written in SAM syntax. And you do that with the first 2 lines of code. And this is really important, because remember that when you upload it to CloudFormation, CloudFormation needs to know what syntax it's written on, so that it can transform it into a fully blown CloudFormation template. Now, to show you how much work SAM is doing for us, have a look at the transform template for this SAM template. It looks something like that. Look at all the code that you didn't have to write. SAM is indeed a hard-working squirrel. So after you've defined what syntax is the SAM template written on, you'll list all of the resources in the same way that you would with CloudFormation. In this case, I am creating a single resource called calculator add. And because it is a Lambda function, I need to give it the type AWS Serverless function. Now, when you define Lambda functions with SAM, you can configure a couple of properties. Some of those are mandatory, like the handler and the runtime, and others are optionals, like the function name and the memory for that Lambda function and the events, for example. Now, the event property is really powerful because it allows you to do two things at once. First, it defines what service is going to be able to trigger, service or services are able to trigger your Lambda function. But secondly, SAM is smart enough to go out and create and then manage that resource on your behalf. So you're basically defining, in this case, an API gateway as well implicitly. I could have done it explicitly as a standalone resource, but this way I have to write less code. So I chose to go that way. So SAM is making it easy for us to manage and create serverless applications by giving us a greatly simplified syntax. But it's also helping us with the deployment side of things, because it's giving us two commands on the CLI, one for packaging, another for deploy. The first one grabs all of the artifacts of your code, uploads that to S3, and then creates a package template with a location of your code. And the second command simply executes all those changes in CloudFormation on your behalf. So all you have to do is to run two commands in your automated release process, and then your serverless application is going to be updated. Enough talk for now. Let's go to our first demo. So in our first demo, what we're going to do is we're going to create a simple calculator. It is very simple, yet really powerful. Simple because it's only going to do one thing. It's going to do addition. You give it 2 query prompts, and it's going to return the addition. But it's powerful because it's going to be built entirely on serverless technologies, which means, among other things, that I could have one user hitting this, or we could have 1 billion of users hitting this, and it should work. So I'm going to be using the SAM template and the SAM commands in order to create and update my application. I'll be using the AWS CLI as well. So if you're not familiar with it, don't worry. You can automate that with your preferred tool of choice. And lastly, because this talk is about not only speed, but safety, I'm going to be introducing a safety mechanism to prevent bad code from impacting all of our users. And this is how it's going to look like. After I create a second version of my Lambda function, I'm going to run a validation to make sure that this second function is also adding. Because if it's not adding, I'm going to roll back. But if it is adding, I'm going to promote it and point all the traffic to my second version of the Lambda function. So let's do it. Let's go back to my laptop, please. Now, in the interest of time, I'm constantly running out of time. Maybe it's a South American thing. So I've done 2 things. One is I have all my commands here for copy and paste, because it's just faster that way. And also, I pre-deployed my stack when I was down there to save some time, but don't worry. I'm going to be using the same SAM package and SAM deploy commands in order to update the stack. So let me show you what I've got here. This is the SAM template that you've seen before. I think I might have added a function name, I believe. But apart from that, it's identical to what you saw in the slides. I'll show you my code. So this is going to be written in Go. It's a very simple function. What I'm doing is I'm grabbing those 2 query prompts coming in the HTTP request and saving them into variables, and then defining the result. Now, this should be an adding calculator, but I'm making an intentional mistake, and that intentional mistake is there because I want to update it to fix it, to show you how it works. And then I'm simply returning that result as part of the body of the response. Very simple function. So what I'm going to do now is let's test my application to see it should be adding, but it's not going to be adding because I have a mistake. So I'm giving the query prompts 4 and 3. And I'm getting a 12. A 12 is not addition, so this is obviously wrong. Let me do one more. Let me do 4 and 4. Obviously, we have a mistake in our code. So what I'm going to do now is I am going to fix it and try to push that change. So I'm going to save this for addition. And now, because this is Go, I need to compile it first. And then these are the 2 commands that we talked about. The SAM package and the SAM deployed. You need to pass it the template that you're using, the S3 bucket where things are going to be uploaded to. And then it should take, among the 2 of those, about 50 seconds. So while that happens, and hoping that it works, I'm going to show you the security mechanism that we're going to be implementing. So the security mechanism that we're going to implement is based off a feature called canary releases for AWS Lambda. So for those that aren't familiar with canary releases, it's the concept by which you release your new version of the application, in this case, a new version of Lambda. You point a small percentage of traffic to it, real traffic coming from users, and you make validations, and you test that this actually behaving correctly. And if it is, you can promote the canary to receive 100% of the traffic. But if it isn't, you can easily roll back. Now, the good thing is that SAM has integrated prepackaged canary releases for us that we can implement really easily with just a couple of lines of code. And you do it this way. So it works as an additional property to your Lambda definition, and it's called deployment preference. There are a couple of types, and these are just two that I'm going to briefly explain. Canary 10%, 5 minutes means it's going to point 10% of the traffic to your canary, to your newly released version of Lambda. And if provided that within 5 minutes, this alarm is not triggered, then it's going to be allowed to transition to 100%. So that is one of the prepackaged options. Another one is a little bit more conservative. So you point 10% of the traffic to the canary. And provided that that alarm is not triggered, in 1 minute, it increases the traffic by 10%. So at the end, with this second option, it's going to take 10 steps before your canary is actually fully promoted. And you also get a couple of toys here. Code deploy is working in the background with SAM to allow these predefined canary releases. And these are just to integrate it to your existing CI/CD pipeline. Now, I was a bit cheeky, and I didn't show you the bottom part of my template, and I've already implemented this safety mechanism. So the way I did it is by having an all-at-once type. Now, all-at-once is not a canary release. It's going to go and deploy everything immediately. However, I've introduced a validation as a pre-traffic hook to my application. And this validation is doing what I explained before, checking whether the second version of Lambda is actually adding before we point any traffic to it. And if it is, promote it. If it isn't, roll back. So let's see if my deployment actually worked. So we have here that this was successfully deployed. Let's test it. The calculator should be adding now, hopefully. 7, OK. 4 and 4 is 8. Fantastic. So it's adding now. But now let's test the safety mechanism at work. Let's try to break this by changing the logic here. Let's say that I'm going to do something else that is not addition, and I'm going to try to deploy that. Now, this is going to take another 50 seconds. So I'm just going to leave it working while we go back to my slides, please. OK. So you've seen how we're gaining speed when we're developing serverless applications with the help of SAM, because now we have a greatly simplified syntax to define those serverless components. We're also getting speed in deployment because now we have only 2 commands that SAM is giving us, so that there's less process to change serverless applications. And finally, you saw how easy it was for me to implement canary releases for Lambda. Well, actually, I didn't do that. What I did was a safety validation. But you saw how easily integrated it is with the SAM template, only 4 lines of code that I wrote. Now, let's think for a moment about the process I went through. I got in the zone with the jazz. I authored some Lambda code. I deployed it. And only after deploying it, I had to wait for about 50 seconds. And after it was deployed, I could test it. I found a mistake, and then I went back to authoring, changed the mistake, then tried to deploy it again, and have to wait another 50 seconds. If you're like me, this is bad. This is really bad. We don't like waiting when we're in the zone creating, authoring, testing, and debugging code. So we're going to need a better flow. And a better flow would be something like that. So imagine if you could have a tight author, test, and debug loop where you can, and this is the normal way we develop applications that are not serverless, right? We have everything in our machine, and if we're using the right tools in the right way, if it works on my machine, it works in the cloud. So imagine if you could have that for serverless applications as well. Now, the issue is that Lambda runs in the cloud. It runs on Greengrass devices. But how do I bring Lambda to my local machine? Well, this is exactly where the second tool that we're going to talk about today comes from, and it's the SAM CLI. It's a local tool for testing, debugging, and deploying of serverless applications. And it's a big thing, because now it means that I can work on my serverless applications without waiting, without interruption, and as an added bonus, maybe without internet, because I can basically mock and test Lambda in my local machine. So pretty cool. Now, the way it works, the SAM CLI, is by using a Docker image that basically you download into your machine, and it mimics the Lambda execution environment, emulating things like memory and timeouts and things like that, and the runtime as well. So what we're going to do is, before we do, let me explain a little bit about the SAM CLI. So there are a bunch of things that we can do. I'm not going to talk extensively about them because we're going to do them in the second demo. But you can create a sample app, so you can get started really easy with any of the languages that Lambda supports. You can test your Lambda functions in a couple different ways, and I'm going to show you in the demo. But the good thing is that you can run now automated tests in Lambda-like environments in your local machine. So the same tests that you run as part of your release process in your CI/CD pipeline, now you can run locally, giving you more confidence that your code is actually going to work. And it's also a game changer in the way that it allows you to quickly iterate over your functions with hot reloading, all in your machine, even without internet. So let's go for a second demo. In a second demo, I'm going to be using well, in the second demo, we learned that our users don't want to be adding anymore. They want to be multiplying. Who would have thought that? Now, so what we're going to do is we're going to author a new function, this time written in Node. We're going to deploy it side by side with our application. I'm going to be using the SAM CLI in order to author, test, and debug the application. But the reason I'm deploying it side by side is because I want to show you another feature for safe releases. And that other feature for safe releases is canary releases for API gateway, so that you can gradually roll out new APIs or new API configurations in a safe manner. And this is how it looks like. So I'm going to create a new configuration stage new stage configuration in my existing application. But that configuration is going to be backed by my new Lambda function. And I'm going to point a small percentage of traffic to it, and then gradually roll it out if I'm happy with the results of my experiment in Node. So it should end like that. So I'm transitioning, but this time I'm transitioning in API gateway configurations. So let's go to my slides, please. OK. So before I jump into the second demo, I want to show you that the safety mechanism in my first demo actually worked. You can see that it actually failed, but it's not giving me much information apart from fail. So what I'm going to do is let's test the endpoint and see if it's still adding. And it's still adding. So you can do 9 and 3, so still adding. And I'm going to show you some CloudFormation events to see if there's any sign of rollback in my CloudFormation events. And there you go. So you can see the code deploy actually rolled back. So the safety mechanism that I implemented before actually worked, which is a good thing. So let's go to our second demo. OK. So before I do so, let me show you some of the artifacts that I have. So I have a SAM template to define my new multiplication function, shorter than the one I had before, because now I'm not defining API gateway. Remember that I'm going to be deploying it side by side. So same thing, in this case, just with a different runtime. And let me show you the code. The code is written in Node as well, extremely simple. So I'm doing the same thing that I did with Go. So I'm grabbing those two query params, then defining the result, and making another mistake. Remember, our customers want to be multiplying, and this thing is not multiplying, but I'll do it so that I can actually test it and fix it. And then returning the result as part of the body of my HTTP response. OK, so let's get started with all the cool things about SAM. First, SAM is a CLI tool. You install it with pip. And you can check the version. Right now, I'm running the 0.5.0, which was, I think, released about 2 weeks ago. One thing you can do with SAM is you can validate your SAM template. Sorry, with SAM CLI, you can validate your SAM templates. And this is a best practice. So you should do this both locally and then as part of your CI/CD release in the same way that you would with CloudFormation. So you can see that my template is valid. Beautiful. So let's test a couple of ways in which we can test our Lambda functions locally. So the first one is, sorry, before I get there, let me show you one more thing. And I want to show you this because it's extremely easy to get started. And there's a command called SAM init that basically creates an app, a boilerplate app in whichever language you want. So I've talked about Go, I've talked about, Node, so I'm just going to create a boilerplate app in .NET Core 2.0 and show you briefly what it creates for me. Where is it? OK, SAM app. So you can see that it creates a SAM template as well with, I don't know, looking more beautiful than the one that I'm using for my demo. And you can see there's an entry. It creates also a Hello World app in C#. And there's an entry point. I believe the entry point is here. So here's where the handler is pointing. So it gets you started pretty quickly, and you can test the app. But I'm not going to be using that app. I'm going to be using the one that we talked about, the multiplication function. OK, so a couple of ways you can test your Lambda function. The first one is testing it in response to a request to an API gateway. So we're actually going to be mocking API gateway in my machine. And you do it with this command, the SAM local start API. I'm running this option of skip pool image because this normally downloads the container into my machine every time that I do this, and I don't want to be doing that because I don't trust the network. So this is a command that basically creates it gives you a port where you can point to in order to test responses of your Lambda function in your browser. So what I'm going to do now is go to my browser. That's really small, so let's do this better. So I'm going to test it with the query params 4 and 2. Let's say 6. So this thing is not actually multiplying. This is the mistake that I had. So what I'll do now is I'll go back to my code, and I'll fix it. So this should be multiplying. I'm going to save this, and I can immediately swipe across and refresh this. And it's going to be using immediately the newer version of my Lambda function. This is all running in my machine, in my browser, with no internet. So it's pretty cool. You can quickly iterate over your functions with hot reloading. Let's test it with something else. Let's say 4 and 9. There you go. So it's actually multiplying, which is good. So this command is also providing us with the logs that we normally would get in CloudWatch logs. We have it here in our machine. Making it easy for us to debug and troubleshoot if things don't go our way. So that's pretty cool. So that's one of the commands. Another command that was recently launched, and I just want to tell you about it, and we're going to be using it, is SAM local start Lambda. So it works in the same way that the API gateway one. So it gives you an endpoint in another port, and it means that now you have an endpoint of Lambda in your machine. And this is pretty cool, because it means you can run those automated tests against your machine. You obviously need to make some tweaks in your code, and I show you what I mean by that. So when you're using your SDK, and in this case I'm bringing Python here, instead of just creating your Lambda client like that, just pointing to Lambda, you need to specify the endpoint. So you need some logic when you are actually implementing this locally in order to run those tests locally. But it's cool that now you have a Lambda endpoint in your machine. So that's another way. Because I'm happy with the multiplication, let me briefly deploy this. I'll show you a couple other things we can do with SAM. But I'll do it while it deploys, because it's going to take about 50 seconds or so. OK, so let me go kill this. And I'll show you one more thing. So this one more thing is the SAM local invoke command. So you can simply invoke Lambda without having to deal with endpoints. And you do it by pointing to the resource, to the Lambda resource written in my CloudFormation template. But because this is a Lambda execution, you need to provide it with an event. So in this case, this request JSON. And so the way that you do that is by generating an event payload. Now, it turns out, I lost my command here, but I'll show you. So there's a SAM local generate event. It goes something like SAM local generate event. And you can choose things like S3 and API gateway. So I'm not going to run the command, but hopefully I have the output here. I have it here. So I'm basically creating a payload of what API gateway would normally send Lambda function, and I'm giving it the two query params, 4 and 2. So what I can do now is I can invoke that Lambda function pointing to that request JSON that you've seen. This is what happened, of course. I have it here. So here's the SAM local. I was going ahead of myself. So this is the generate API, and I'm going to run it. Let's OK. So I'm going to run it. And you can see that it generates the payload, and I save that payload into a file. So what I can do after that is I can invoke it by pointing to that event. So I'm pointing to that event here. And what this is going to do is execute that Lambda function with that event payload and giving me the result. So 4 times 2 is 8. I'm getting my result, and I'm also getting the logs so I can easily troubleshoot and debug. The last thing that I'll show you is this command that I was getting ahead of myself, which is live debugging. So you can do live debugging as well on your IDE by simply adding the -d option with a port. And so I'm going to be executing the same command, the SAM local invoke, with the same query param. So it's 4 and 2. It should be multiplying and be 8. But when I do this, it actually allows me to debug with any debugger that I have. So what I've done is I've pre-configured my IDE to listen on that port. So if you have a breakpoint into your line, I can go into my debugger, hit the debugger. And you can see that I'm debugging my Lambda code in my machine with SAM CLI, no internet required. So I can inspect here. I have all the variables defined here. I can inspect my code. I can step over this line of code and see what the result of this is. Now it's a string with the number 8. So you would debug it in the same way you would any non-serverless code. Pretty cool, hey? So so this is all the things that I want to show you about the SAM CLI. But because this is also about security, let's implement those canary releases for API gateway. First, let me grab the Lambda that I've just deployed so that my commands work. So the way this works is I currently have an application that is with its API gateway that is adding. It's using my node function, sorry, my Go function that I had on the first demo. And I have this standalone multiplication function written in Node. They don't know about each other. So what I need to do is basically let API Gateway know about this to create a new stage configuration, and let Lambda know about that by adding a permission. So these are 2 commands that I'll be running on the CLI, and I want you to memorize them, OK? So these 2 commands, what they're basically doing is exactly that. So they're creating a stage in API Gateway, and it's called adding a put integration. And in Lambda, I'm just adding a permission. So when you run that, now they know about each other. And after they know about each other, then you can create your canary release. So you do it with the API Gateway create deployment. I'm using the same stage that I already have, that is called prod, but I'm giving it a canary setting with 20%. Normally, a canary, you would do it with less, but I'm doing it with 20% because it's easier to show you that 20% of the traffic is actually pointed to the multiplication function. So once I test my application, it should be coming 4 times out of 5, roughly, with addition, and 1 time out of 5 with multiplication. So let's see if it works. It's going to work. 4 and 3, so that's addition, 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 multiplication, addition, addition. Well, you can see it's about 20%. If you do something else, there you go, addition, multiplication, yeah, 20%. So really cool. So what I can do now is, if I am happy with the result of my canary, then I can promote it. And that promotion, you do it with this command, API, so updating the stage that I have. The existing stage has a canary release settings. So what I need to do is I need to copy that canary release settings into the main deployment ID. And when you do that, then 100% of the traffic is going to be pointing to my multiplication function, and I'm running out of time. So I'll show you quickly how this pans out. So it should be multiplying all the time now. There you go. Beautiful. I love it when demos work. So let's go back to my slides. So you've seen how the SAM CLI is helping us gain speed in the software creation because it's bringing all the Lambda, all the good things about this SAM and Lambda into our local machine so that we can create those serverless applications without waiting, without interruptions, and perhaps without internet. We can have that tight author, test, and debug loop. You've also seen how easy it is to implement, arguably easy, and I hope you memorize those commands, to implement canary releases for API Gateway so that we can gradually roll out new APIs and new API configurations safely. Something else, and Jeff Barr alluded to it this morning, he said that we at Amazon give freedom to the developers to use whatever tool. And this is key. You should be using the right tool for the right job, or maybe the tool that you're comfortable with. And you can see how I basically had 2 different programming languages in my same application. And this is good. That freedom gives developers also and help with the speed when they release the software projects. So, I want to encourage you, next time you sit in front of your IDE, to deliver your software faster by making it serverless, but also deliver it safely by implementing canaries. Thank you very much for attending the session. Please give us feedback. As you can tell, I am very passionate about serverless applications. I believe they are the future of application development. So I hope that you've learned something today and that you're going back to your workplace tomorrow empowered to build anything serverless, anytime, anywhere. Thank you.